Okay, so yesterday we learned about the Bohr model. We learned that Bohr model, he puts electrons in energy levels, right? But that's still not super specific because as we learned, some of those energy levels can hold up to 32 electrons, correct? So if they can hold 32 electrons, if I tell you that they're in the fourth energy level, that's still not telling you a whole lot about them, correct? So Schrodinger came along and he said, well, we need to be a little bit more specific. So he created a model in 1926, which if you remember the Bohr model was 1913, so we're about 10 years apart. And this model does not include a direct path the electron takes around the nucleus. Bohr said electrons travel in nice, pretty circular paths. Schrodinger said they're probably not nice, straight orbitals. We're probably something else. And so what he did is as opposed to telling you exactly where electrons lived, he said there is a most likely spot for an electron. Okay? Can we see electrons? No. Can we see can we weigh their mass? No. Do you think we can actually find a location of them? Probably not. So, if we can't see them, we can't find their mass, we can't look at them, how in the world are we supposed to find their location? Well, I like to compare it to something, a propeller blade. Think about airplanes, think about helicopters. When their propellers are going, can you see the propeller blades? No, but how do you know they're there? Can you still see them? Yes, can you see a specific propeller blade? No, but you can see them because, like, for instance, if the propeller blades are white, you see a white blur, right? If the propeller blades are red, you see a red blur. Now, can you tell me specifically where that propeller blade is? No, but I can tell you, oh, it's in this circumference, right? It's approximately in this nice, pretty circle. I can't tell you where exactly, but it's here. So that's what Schroeder said. He said, I can't tell you their exact location, but I can tell you what orbital they are in, okay? So, basically what he says is I can tell you where the electron is 90% of the time. So where do you think it is the other 10% of the time? It is probably quantized, which means what? It is gaining energy to move energy levels. So it's kind of like, are you guys at home all the time? No, obviously, you're in class right now. Do you live at your house? Yes. Does that mean that you're there 100% of the time? No, but don't you always go back home at some point in time? You start at home, you leave. Most of you start out at home in the morning and you come home at night, right? You might go places during the day, you might go back home several times throughout the day, but you always start there, you always end there. Electrons do the same thing. Okay? They have a home and they start there and they end there. Okay, but since he's trying to be more specific than just an energy level, he had to come up with a different name. So he came up with something called an atomic orbital. This is the location of your electrons. This is your high probability of finding an electron. If you use the Schrodinger equation, which I won't make you do because that's mean, you'll be able to find the energy an electron can have. Okay, so basically Schrodinger, he puts electrons in energy levels and then he's a little bit more specific and he puts them in an exact orbital. So instead of just saying, oh, all 32 of my electrons are in the fourth energy level, he says, no, they're in the fourth energy level, but they are in a specific orbital. So basically, he's giving you an address for the electron. So there is a little bit of a problem when I say energy levels. Does anyone know? Can anybody tell what the problem is? If I say, where is this electron in the energy level? I'm being a little vague, correct? Because I'm not talking about all 7 energy levels, I'm talking about a specific one. So we have to have some sort of way to communicate what energy level we're talking about. Okay, how many energy levels are there? 7, so we just number them. These energy level numbers are given a name. They're called a quantum number. Okay, number, shorthand, n. So if I say n equals 3, I'm telling you I'm dealing with the third energy level. If I say my quantum number is 5, I'm telling you I'm dealing with the 5 energy level. But the reason we give them quantum numbers is because in a second, over the next few days, we're going to be building up how to write electron configurations, which is an address for an electron. So, do you guys want to write out 5 energy level orbital S, third house every single time? No, so we're trying to learn a shorthand. So instead of writing third energy level, you just write 3. 3 means we're in the third energy level. For each principal energy level, there are several orbitals with different shapes and at different energy levels, and we call these sublevels. So you have your level. Within your level, you have your sublevels. There are different types of sublevels, and then within the sublevels, you have a specific amount of orbitals. Level, sublevel, orbitals. Kind of just like an address. Okay. Each energy sublevel corresponds to an orbital of a different shape, which describes where the electron is likely to be found. So, so there are orbitals with different shapes and different amounts of energy. I always like to compare these things to our planetary orbits because you guys have all seen that. You've dealt with that since you were in 2nd grade, right? So let me ask you a question. Does the moon orbit the sun? Yes. Directly? No. What does the moon do? He orbits the Earth, but at the same time, he is revolving around the sun. So does he orbit the sun? Yes, indirectly. He's orbiting the Earth, but the Earth is orbiting the sun, so technically he's moving around the sun as well. Okay, this is the same basic concept. Electrons do not orbit the nucleus. They orbit in their sublevels, but their sublevels are orbiting the nucleus. So yes, but indirectly. Okay, well, there are several types of sublevels. They have different shapes. They have different energy levels, and we'll talk about the energy levels next week. But today I want you to learn the different shapes. This is one of those things in chemistry. I say this very rarely. This is something you're just going to have to memorize. There is no easy way to remember this. You're just going to have to flat out memorize that. You have 4 different types. They are the S, P, the D, the F. The S orbital only has 1. In every energy level, you can only have 1 S orbital. Okay, it has a spherical shape. What kind of shape do you think a spherical shape is? Circular. P orbitals, in every energy level, we can have a maximum of 3. We never have 1. You either have 0 or you have 3. You either have P or you don't. You can't ever have 1, 2, or 3. You don't always have to use all of the orbitals, but all 3 of them are there. The D orbitals, you have 5 of them, and then the F orbitals, you have 7. And again, we're doing pieces of the puzzle. This will all kind of come together nice and easy for you. Okay, so here is what they actually look like. If you can see, S orbitals, they're pretty simple, aren't they? They're a sphere. This is what the Bohr model shows us, right? Oh, nice, pretty circular. And but if you remember, Bohr just studied hydrogen, so wouldn't that make sense he was only studying 1 electron, so that would make sense. He was studying the most simplest form. But as we move on, we get more and more complex. So P, remember there are 3 of them. D, you see the clover leaf shape? Kind of looks like a 4-leaf clover. And then F, can I really try to define the shape of F? Kind of looks crazy to me, correct? There are 7 orbitals all trying to exist at the same time, so it's going to be a very complex shape all at the same time. So, like I said, we are trying to learn how to write addresses of electrons. That's the whole point in trying to do this. So, how do you write an address? Sometimes I get a little worried we don't even know how to write an address. So if you're writing a letter to somebody, how do you write an address? You do name. Then what do you do? Street. State. City, right? Actually, you do city, state, sorry. And then you do zip, correct? If you just put, oh, I want to send a letter to Brianna in Monette. What's her last name, first of all? What street does she live on? Well, do you think there's probably a Monette in a different state? Probably. So the mailman would probably be like, huh, and throw it away. Okay, so we have to come up with another way. So let's think about what we just did. We talked about energy levels. How do I represent energy levels? With a number, correct? N. Okay, then underneath energy level, we talked about having sublevels. What are the sublevels? S, P, D, F. After sublevel, we have specific orbitals. How many orbitals are in S? 1. How many are in P? How many are in D? How many are F? 7. So if I'm trying to give a specific address, I would maybe say 1P3. What is that telling you? First energy level, P sublevel, third orbital. So I'm giving you directions to an orbital, correct? But at the same time, I'm doing it in shorthand. Okay, so each energy level has a different amount. Okay, so I'm going to go over the first 4 energy levels. I'm going to break it down nice and pretty. Sublevels, orbitals, so on and so forth. So let's look at the first energy level. The first energy level, which if you look at the periodic table, how many elements are in the first energy level? 2. So how many electrons? A maximum of how many electrons? 2. So do I need very many orbitals? No, because I haven't told you this yet, but one orbital can hold 2 electrons. So how many orbitals do I need to hold 2 electrons? 1. So that's why in the first energy level we only have the 1s sublevel, which means we only have 1 orbital, right? Okay. Well, let's look at the second energy level. How many elements are in the second energy level? 8. So how many electrons do we worry about maximum? 8. There are 8 elements, so at maximum I need houses for 8 electrons. So how many orbitals am I going to need? Each orbital can hold 2 electrons, so how many orbitals do I need? 4. Well, S didn't have 4, P didn't have 4, D didn't have 4, F didn't have 4, so I'm probably going to need a combination. So you always go in order too. So in the second energy level, again, it's going to have another S orbital. There's 1. And then next we're going to throw in some P orbitals. So if we have 1P or 1S and 3P, how many total do I have? 4. So is that going to hold all 8 of my electrons? Yes. Okay, another thing is 2P has more energy than the 2S sublevel. Why? Why do you think it would have more energy? It has more orbitals, it has more electrons, right? So it's going to have more energy. Okay, so let's go to the third energy level. How many electrons can the third energy level hold? 18, so how many orbitals do I need total? Each orbital can hold 2 electrons, so if we have 18 electrons, I need 9 orbitals. So it's like houses on the street. I need 9 houses to put all of my electrons. Well, S has 1, P has 3, D has 5, and F has 7. None of those are 9, correct? So I'm going to need a combination. And again, we're going to go in order. So the third energy level is again going to start over at S. So it's going to have 1 S orbital. Then it's going to have 3 P orbitals. And it's going to have 5 D orbitals. 1 plus 3 plus 5 equals 9. So now we're up to our 9 orbitals. So I have a home for all of my 18 electrons. Are all of these houses going to be full? No. But that's okay. They don't all have to be full. They just all have to be there. Let's go to the fourth energy level. The fourth energy level has to be able to hold 32 electrons. So how many orbitals does this one need? 16. So what do you think we're going to do? We're going to start over at the S orbitals. Then we're going to move on to the P. Then we're going to move on to the D. So now we're at 9. but we need 16, so I'm going to have to move on to the F. So 1 plus 3 plus 5 plus 7 equals 16. So now we have our 16 orbitals. Every energy level kind of starts over at S. Every single time you move energy levels, you have to start back at S. So the first energy level has the S orbitals. The second energy level has S and P. The third has S, P, and D. And the fourth has S, P, D, and F. What do you think the fifth has? It can hold 32 electrons. What do you think? How many orbitals does it need for 32 electrons? 16. So what types is it going to have? S, P, D, F. What about the sixth energy level? It can only hold 18. 9. So it's going to have S, P, and D. The seventh can only hold 8. So it's going to need S and P. Okay, process, right? So this we should already know. We talked about this yesterday. The first energy level can hold 2 electrons. The second can hold 8. The third can hold 18. The fourth can hold 32. And then it starts going back downwards, correct? Okay. So I don't know about you guys, but memorizing all of that doesn't really sound like fun, correct? So what does this look like to you guys? The periodic table, correct? Well, if we can learn how to read the periodic table, we don't need to memorize this. The only thing you'll have to memorize is that there's 1s, 3p, 5d, 7f. If you can memorize that, the rest of it is just how to read the periodic table. So let's see if we can do this. So chlorine is right here. Okay, so let's see if we can figure out where all of chlorines, let's see if we can figure out how many sublevels. Let's see if we can figure out how many P's he has, okay? So what you do is you start all the way back at hydrogen every single time. So hydrogen starts off with the first energy level. What kind of sublevel? S. The red ones are all S's. So he's going to put electrons in 1s first. But he needs 17 ohms, and that only gives him 2. So he has to keep going, right? So then he starts back down here at 2s, and he's going to go here. So now we're at 4 ohms. But we need to get to 17, so are we done yet? No. So then he starts to put electrons into the 2p sublevel. So now we're at 2 plus 8, we're at 10. Do we have 10 ohms? We need 17, are we there yet? No. So then he starts back down here, we're reading this like a book, right? Then he starts putting electrons in 3s, which then puts us at 12. Are we there yet? Nope. So then he has to start putting electrons in the 3p orbitals. Oh, we're finally home. Chlorine lives in the third energy level, in the p sublevel, and specifically in this orbital, right? Do you guys see how I read that? Do we need to memorize anything? No. Tuesday we're actually going to color code the periodic table. You're going to get your own handy dandy one that looks just like this. But let's do another one. Let's do potassium. Potassium was on your homework last night, right? Potassium is right here. Where am I going to start when I'm writing the address? I'm going to start right here. So first of all, potassium is going to put electrons in the 1s, correct? So there's homes for 2 electrons, right? So next we need to find homes for the rest of them. So we start in what sublevel? 2s. We're just reading this like a book, right? Are we to my potassium yet? Nope. So we keep reading. Next we put electrons in 2p. Am I to potassium yet? Nope. So next we put electrons where? 3s. Am I to potassium yet? So where do I put electrons next? 3p. Am I to potassium yet? Almost. So next potassium is going to put electrons where? 4s. Yay, I'm here. I get to stop. Does anyone notice, what did we skip? Isn't this the third energy level? So this is why our Bohr models were not working out yesterday, because we didn't put electrons in our 3d orbitals first, did we? We put them down here in our 4s first. Then we put electrons in our 3d, which doesn't really make sense, but it's a rule. Okay, do we need to memorize that rule? No, because I'm teaching you how to read the periodic table. So do we need to memorize anything? No, because we are going to make one of these that you guys get to keep and use on the test. Okay? All right, so Tuesday we're going to make a periodic table. Tuesday we're going to learn some of the rules and how you fill electrons and what order you fill electrons. But before we can do any of that, you have to know what sublevel is. You have to know what quantum numbers are. You have to be able to figure out what types of sublevels. You need to be able to count orbitals. You need to be able to count electrons. If we can't do this, we're not going to be able to do the addresses, right? So here's your homework. It's 4 questions. It's on the website. You should probably title it Atomic Orbitals. I give you the date. Remember, for your homework quiz, be sure you put both of these items so that you can find it. Answer these to the best of your ability. Okay? Any questions? No. Nope.